Okay, so we're continuing our nomenclature for the unit, which is naming and formula writing. We're going to start with acids, acid nomenclature first. And so sulfuric acid is one of the many acids that we're going to learn how to write the formula and how to write the name from the formula. All right, so first thing I need for you to do is you have a notes sheet, but on that lined paper that you are going to put that notes sheet on, let's put this concept map down. And we will be filling this in as we go through the three different types of bonding. So we're going to do ionic first because acids are actually just a type of ionic bonding. So you already have a foundation for what we're going to do for naming these. That's cool. We're just going to add a little bit to it. And then we'll talk about metallic and covalent bonds and some more information about that. So draw this, pause as you need to. We're going to have ionic on this side of our chemical bonds concept map. Remember that ionic compounds are composed of metal cations, metals form cations, or if we're dealing with polyatomic ions, it could start with ammonium, the NH4 with a +1 charge. And we also have non-metal anions. That's always going to be the last thing. So what we have been looking at are actually all salts, whether it's sodium chloride or sodium carbonate. Those are all salts. They have a cation in the beginning and an anion in the end. What we're going to talk about now is specifically acids. Acids are a type of ionic compound. Their cation is always going to be a hydrogen ion, so that makes them very easy to identify. And then they're going to have any anion for the ending. It can be any anion. When we get to bases, bases are going to start with any cation. There can be whatever cation you want to be able to use, but bases specifically will end with a hydroxide, OH. And so that's the first thing we need to get is that ionic compounds can be salts, they can be acids or bases. Naming these compounds are pretty much the same except for acids. That's what we're going to have to add to our repertoire of naming, of nomenclature. All right, so you have this here, but you don't have it filled out. So what I need for you to do is go ahead and pause the video and fill this out. The anion, remember we said that all acids are going to have hydrogen ions? Well, they're also going to have an anion, and the anion can be monatomic, like chloride, so the ending would be ide, in which case we would have something called hydroic acid. If we have chloride, then that's hydrochloric acid. We just take the stem of the anion and plug it in there. If we have a polyatomic ion that has an ite ending, and this is the thing to be able to recognize the difference of. We have ide if it's monatomic, ite if it's polyatomic. And there is a difference. So the polyatomic means that there's going to be some oxygens. Sometimes we call those oxyanions. So there's going to be some oxygens present there. If the ending is ite, we call that a chlorous acid. And see how that has that hydrogen in front? That lets you know that that is an acid. This is the anion. This is the acid. The third and final part of acid naming is if we have an ate ending for the anion. So remember, ates always have one more oxygen than the ites do. So if you remember all of your ates, that's going to make it very easy for you to remember what the ite is, because it's the exact same charge, it just has one less oxygen. If you have an anion that ends in ate, that's going to be an ic acid. Notice there's no hydro in the front here. We only use hydro if it's an ide anion. So chlorate, when that ion is paired with hydrogen ions, that becomes chloric acid. And I know it's an acid because it starts with hydrogen. Not hydrochloric acid, that's only with the chloride ion, but chloric acid, that's with the ate. Okay, so we can go back and forth. We can take the name and figure out the formula. We can have the formula and then figure out the name just using that set of rules. So let's go ahead and look at some examples that you have. So if we are naming this first acid here, and I know it's an acid because it starts with a hydrogen ion, then I need to look at the anion. Everything after the hydrogen is ClO. If I look at that on my polyatomic ions chart, I see that that is hypochlorite. So looking at my table, my rules for naming, if it ends in ite, that means I'm going to change the ending of the acid's name to us. So I'm going to keep the rest of this. It's hypochlor, but the acid name is going to be an us acid, so it's hypochlorous acid. And that's the name of that one. If we move on to the next one, I know it's a hydrogen again because, an acid because it starts with hydrogen. So I look at everything else behind that. And this is where memorizing your polyatomic ions helps you to get through these quickly and build on your knowledge. This is phosphate. If it ends in ate, then that means it's going to be an ic acid. So this is phos. If you said phosphoric acid, it would be correct, but just know that by convention, we keep that extra syllable in there. That's phosphoric acid. Okay? Let's do the next one. This was actually in our example. So this is hydrogen, that's an acid then. Anion, chloride. So our name is going to be a hydroic acid. So it's hydrochloric acid. All right, let's do a few more. H3BO3. Okay, so this is borate, if I'm not mistaken. Borate is an 8 anion. So if it ends in 8, that means the name of the acid is going to be an ic acid. So this should be boric acid if we did it right. Yay, boric acid. Okay, pause the video and try the next 3, and we'll go over those together. So pause them, try them. I'm going to go over the answer for the next one, so hope you've done it. All right, so the anion here is sulfate. All 8 anions become ic acids, so this is sulfuric acid. Again, if you put sulfic acid, you're following the naming rules. It won't be technically wrong, but just know that you're going to see it as sulfuric acid. HNO2. Who's the anion? Nitrite. So according to our table, nitrites, ites, become us acid. So instead of nitrite, this is nitrous acid. HI. So hydrogen is the cation. The anion then is iodide. It's an ide ending, which means I'm going to have to put a hydro in the front and then an ic at the end. So this is hydroiodic acid. That one's kind of tricky. Sounds weird, but that is what it is, hydroiodic acid. Okay, so now let's do the next one. Don't pay attention to that little thing you saw, just keep on working. So it does not matter. Remember that this is like in any other ionic compound. It has a first name and a last name. It's an acid, so that first name, that first part, is the hydrogen. That means everything else behind it has to be one thing. On your polyatomic ions chart, that is acetate. It's an 8 ending, so it's going to be an ic acid. So that becomes acetic acid, which is just regular old vinegar, acetic acid. Okay, take a few minutes, pause the video, try the next few. We'll look over the answers. Did you pause it? I'm going to show you the answers. I hope you tried them. All right, so this is hydrofluoric acid because the anion is an ide. The next one, H3PO3. It's not hydrogen phosphite, it's phosphorus acid. Right? Try the other ones. We're going to work through these little by little, and I'll show you the answers. That's hydrocyanic acid. The next one is chloric acid. Ooh, I love the next one. It's in your sodas. It is carbonic acid. H2SO3, sulfurous acid. HClO2, chlorous acid, because it's a chlorite anion. And HNO3, you all know this one, nitric acid. HBr, ooh, it has an ide anion, hydrobromic acid. All right, so y'all can do that. Let's move on to writing the formulas. Again, we're just going to go backwards. So our nitric acid, it's an ic acid. Ic acid. That tells me that the anion has to end in 8. My base of the name is nitro, which tells me that it's going to be a nitrogen compound or anion. It ends in 8. That means it's polyatomic. So that's got to be NO3, nitrate. Now, nitrate has a -1 charge, so when I put hydrogens with it, again, this is just like any other ionic compound, I have to make sure that those charges balance out. Well, +1 and -1 do balance each other out, so my answer for that one is just HNO3, one of each. Chloric acid. Ooh, again, it's an ic acid, which means that our anion has to be an 8 anion. Chlor is my stem word here, so that means it's got to be chlorate. And if I look that up on my polyatomic ions or have it memorized, that is chlorate. It has a -1 charge, which means that I'm only going to need 1 hydrogen to balance out that charge, and that's my formula. Okay, acetic acid. Ooh, acetic acid. You've got to remember that one. That one people have the toughest time with every year. C2H3O2, 232. CHO. That's how I remember it. It's CHO, 232. Acetic acid. So ic, that means that the anion is 8. C, so that's acid. I just know that that's acetate. That's the formula. It has a -1 charge, so again, I only need 1 hydrogen to go with it. And there are different ways that you'll see this written down. It just depends on, again, what list of polyatomic ions you're using. But for us, we're just going to use this one here because I like it. It's shorter. It's more succinct. Okay. So go ahead and do the next few, and I'll show you the answers. Pause the video. Try it. I'll slowly reveal so that you can check and see if you got it right. Hydrobromic acid is HBr. Trisulfurous and chlorous, I'll show you both of those. Ready? There you go. Hydrochloric acid. All right, now try phosphoric acid and nitrous acid. Here come the answers. Hydrofluoric acid. And by the way, I know that these are all on the other list, but don't look at what we did before. The whole point of this is to work through it. You're only going to get better if you actually work through it. Don't try to look over to the other table and copy it down. That's not going to help you. All right, so hydrofluoric and hypochlorous acid, their formulas are that and that. Hydroiodic acid and phosphorus acid, hi, and H3PO3. Carbonic acid, my favorite. Perchloric acid, HClO4. Permanganic acid I really like because permanganate is one of my favorite ions, so you've got to remember that. Prado's favorite is, oh, that's potassium permanganate. Prado's favorite polyatomic ion is permanganate. Say that 10 times fast. You've got to have that memorized because you're going to see it probably in every single quiz. All right, so your formula for that is HMNO4. And I'm going to let you finish the last two. I'll be checking those in class. If you've gone through all of these, then you should be able to get those last two. All right, good luck.